Good morning, class. This is Francis. Welcome to the third period, period 3. Period 3 on the topic matrices. Okay. So today we will look into a new section, class 4, where our last section we talked about equality of matrices. In section 4, we will look into special matrices. Special matrices. Now there are several types of matrices. There are several types of matrices. There are several types of matrices, but we will study only 2 for the moment. We have the zero matrix and the identity matrix. Okay. Number 1, Roman 1, is the zero matrix. The zero matrices are actually matrices with all their entries zero. That is, for a 2 by 2 matrix, the zero matrix denoted by this is equals to 0, 0, 0, 0. See, all the entries have the value naught. And for a 3 by 3 matrix, denoted by capital letter O subscript 33, we have 0, 0, 0, 0, 0, 0, 0, 0, 0. And so on. Okay, so that is what is zero matrix. So in general, an n by n zero matrix is a matrix with how many columns? With m columns, a total of m columns, and how many rows? Total of n rows. So we have 0, 0, 0, 0, continue like that. So this is an n by m zero matrix. Okay, so that's it. Now the second special is the identity matrix. Now the identity matrix with all the entries in their leading diagonal. One and 0 for the other entries, and 0 for the other entries. Okay, what do we mean by this? We are saying, for instance, for a 2 by 2 matrix, I2 by 2, as the identity matrix for 2 by 2, we have 1 0 0 1. See, this is the leading diagonal. The other entries takes on the value of 0. See, for a 3 by 3 matrix, we have 1 0 0 0 1 0 0 0 1. The leading diagonal takes on the value of 1. The other entries takes on the value of 0, and so on. Okay. Our topic 5 is scalar multiplication of matrices. Now suppose A is a 3 by 3 matrix defined by the matrix A equals to A1, A2, A3, A4, A5, A6, A7, A8, A9, and that alpha is a scalar. By scalar we mean a real number. Then the scalar product alpha A is written as alpha A like this. You have alpha times what? The matrix A itself. Now we use alpha here, multiply each entry. So we have alpha A1, alpha A2, alpha A3, and so on till we get to alpha A9. By definition of scalar multiplication, we mean, by definition of scalar multiplication, as we saw in the definition above, we can obtain some important facts. The first of them is, suppose alpha is a scalar and A and B are matrices, then alpha times A plus B will always be equals to alpha A plus alpha B. If now you have two scalars, let's say alpha and beta, and a matrix A, then alpha plus beta in bracket times the matrix A is the same thing as alpha A plus beta A. The third fact is minus 1 times A is minus A. And the fourth and the last fact is what? 0 times the matrix A is equals to the 0 matrix of size n by n, where this n by n is actually the size of the matrix A. By that, we simply mean if matrix A is a 2 by 2 matrix, then 0 times A will give you the 2 by 2 0 matrix. If matrix B is a 3 by 3 matrix, then 0 times B will give us the 0 3 by 3 matrix. So we'll go straight to example. Find 2A minus A and minus 2A if A is this matrix. You see, as A is this matrix, 2A will be 2 times 0, 1, 2, and minus 3, as you can see here, so that we have 0, 2, 4, minus 6. In the same way, minus A, we saw in our fact above that minus A is identical to minus 1 times what? A, which is equals to minus 1 times the matrix A itself. Multiplying respectively, we have 0, minus 1, minus 2, and 3. Similarly, minus 2A times minus 2 times A gives us clearly what? 0, minus 4. Sorry, 0, minus 2, minus 4, and 6. Now, example 2. If A is a matrix, a 3 by 3 matrix, we have 1, 2, 3, 0, 1, minus 1, 2, 0. And B is the 3 by 3 matrix 0, 1, minus 1, 5, minus 2, 1, 0, 4, 3. Okay? And you have to find 3A plus what? 2B. How do we do that? Or, and 2A, sorry, yeah, 3A minus 2B. Okay. Solution. Now, we first of all find 2A. 2A is clearly 2 into 1, 2, 3, 4, 0, 1, minus 1, 2, 3A, and 0, yeah. And this clearly 3 times 1, that gives us 3, 6, 3 times 3, 9, 3 times 4, 12, 3 times 0, 0, 3 times 1, 3, 3 times minus 1, negative 3, 3 times 2, 6, 3 times 0, 0. Then we look for 2B. That's 2 into 0, 1 minus 1, 5 minus 2, 1, 0, 4, 3. Now this clearly 2 times 0, 0, 2 times 1, 2, 2 times minus 1, 2 times 5, sorry, 2 times minus 1 is minus 2, 2 times 5, 10, 2 times minus 2 is minus 4, 2 times 1 is 2, 2 times 0 is 0, 2 times 4 is 8, 2 times 3 is 6. Okay? Then 3A plus 2B is simply what? 3, 6, 9, 12, 0, 3, minus 3, 6, 0. Okay? Plus 0, 2, minus 2, 10, minus 4, 2, 0, 8, 6. And of course, N3, we do addition entry wise. We saw that in our last period. So 3 plus 0, we have 3. 6 plus 2, that's 8. 9 plus minus 2, that's 7. 12 plus 10, that's 22. 0 plus minus 4, that's minus 4. 3 plus 2, that's a 5. Minus 3 plus 0, minus 3. 6 plus 8, and that's a 14. 0 plus 6, that's a 6. Good. So this is the answer for that first one. Now to get the result for the second, for the other half, we do know that we know already the value of 3A and 2B, so we just take the difference. 6, 9, 12, 0, 3, minus 3, 6, 0, minus 0, 2, minus 2, 10, minus 4, 2, 0, 8, 6. So the difference, 3 minus 0, we have 3. 6 minus 2, we have 4. 9 minus 2, that gives us what? 11. 12 minus 10, that gives us a 2. 0 minus 4, okay, that gives us a 4. 3 minus 2, that's a 1. Minus 3 minus 0, that's minus 3. 6 minus 8, 6 minus 8, that's a negative 2. 0 minus 6, that's a negative 6. Okay, and we are done. 6. Matrix multiplication. Suppose A is a 1 by 4 row matrix and and B is a 4 by 1 column matrix. That is, A is the matrix. You have A1, A2, A3, A4, and B is the matrix. B1, B2, B3, B4. Then the product of A and B, denoted by AB, is defined to be how do I even put it? Is defined to be the 1 by 1 matrix. Yes, the 1 by 1 matrix whose entries are obtained by summing the product of the entries. Okay, by summing the products of the entries in the row matrix, A with the entries in the what? In the column matrix B. That is, AB will be A1, A2, A3, A4 times B1, B2, B3, B4. So we have row times column. That's based on the definition we have A1 times what? Times B1 plus A2 times B2 plus A3 times B3 plus A4 times B4. Okay, good. Now I want you to note something. A is a 1 by 4 matrix and B is a 4 by 1 matrix. This gives us the matrix AB, and AB is a 1 by 1 matrix. Okay, if you look at it very well, it's a bit confused as this 4 gets annihilated and then we are dropped to a 1 by 1 matrix. Similarly, if A is a 2 by 3 matrix, multiply with B a 3 by, let's say, 5 matrix, guess what? AB is going to be a 2 by 5 matrix. Hands on. So we'll start with example 1. If A is 201, find A squared. Okay, of course we both know that A squared means what? A times A. That's 1201 times what? 1201. Based on the note we saw yesterday, we saw in the just now, this is a 2 by 2 matrix. This is also a 2 by 2 matrix. So we are expecting the resulting matrix to be what? 2 by 2. Okay, so this multiplication is possible simply because the number of columns in the first matrix is equal to the number of rows in the second matrix. That's a fact. So note, if the number of column in the first matrix equals the number of rows in the second matrix, then the product of those two matrices exist. Good. So back to our problem, we have 1 2 0 1 times 1 2 0 1. Now remember, it is row times what? Column. So we do 1 times 1, that's 1 times 1. Okay, we add it to what? 2 times 0. Okay, then we do now, after taking row for the first column, we now use the same row but now for what? The second column, and that will give us what? 1 times 2, we have 2 plus 1 times 2 plus 2 times 1. Oops, let me put it up here. 2 times 1. Okay, now this is a square we are working on. Also, now we are taking the second row and do the same thing all around. 1 2 0 1. So we already have 1 plus 0 here, okay, and here we have already 4 plus 2. Now we do 0 times this first column times this first. 0 times 1 is 0 times 1 plus 1 times what? 1 times 0. Then we do same thing as the other. We use the same column, multiply this one. 0 times 2. 0 times 2 plus 1 times 1. Okay, so see that we end up with a matrix. The matrix what? 1 plus 0 into what? 0 plus 0. Here we have 4 plus 2. Here we have 0 plus 1. Okay, and if you sum that, see that a square now becomes 1061. That's it. Example 2. If a is 1042 and b is equals to 231041, okay, find AB. First of all, we need to find out if this particular matrix exists. First, we find out if AB exists. Okay, the matrix A is actually a 2 by 2 matrix. The matrix B is a 2 by 3 matrix. That's 2 rows, 2 columns. Here is 2 rows, 3 columns. Oh, of course, we have the matrix what? 2 by 3 will be the resultant matrix. So AB does what? it does exist. Okay, so we can move ahead and do the multiplication now. So we have 1 0 4 2 times what? 2 3 1 0 4 1. Now we have 1 times 2. Remember, it is this times what? This, and that will be the first entry here. So we have 1 times 2, that's 2, plus 0 times 3, that's what? 0. Okay, we use the same row and multiply this, and that will be coming in here. So that's 1 times 1 is 1, 0 times 0 is what? 0. 1 times 4 is 4, 0 times 1, 1 times 4 is 4, plus 0 times 1, plus 0 times 1 is 0. Okay, 4 times what? 2. Now it is this with the first column, second row, first column, second row, second column, second row, third row, like that. 4 times 2, that's 8, plus 2 times 3, 6, 4 times 1, 4, plus 2 times 0, 0, 4 times 4, 16, plus 2 times 1, 2. See that the matrix we have is 2, 1, 4, 14, 4, and 18. And clearly, this is a 2 by 3 matrix as we predicted here. So it means we are correct. Okay, example 3. Find A, B. If A is this matrix and B is this matrix. Good. AB is going to be 1, 2, 0, 4 minus 1, 5 minus 3, 2, 0, 1, 4 minus 2, 0, 2, 3 minus 1, 3 minus 5. Now, watch. This row times what? First column. First row times first column. So we have 1 times 1, 1, plus 2 times 0, 0, plus 0 times minus 1, 0. The next thing is first row times second column. We fill it here. So we have 1 times 4, 4, plus 2 times 2, 4, plus 0 times 3, 0. Then first row, third column, we fill it here. 1 times minus 2, minus 2, 2 times 3, 6, 0 times minus 5, 0. Same thing, second row, first column, 4 times 1, 4, plus minus 1 times 0, 0, plus 5 times minus 1 is minus 5. Second row, second column, 4 times 4, 16, plus minus 1 times 2, minus 2, plus 5 times 3, that's what? 15. Second row, third column, 4 times minus 2, minus 8, minus 1 times 3, minus 3, 5 times minus 5, minus 25. Minus 3, third row, first column, minus 3 times 1, minus 3, 2 times 0, 0, 0 times minus 1, what? 0. Third row, second column, minus 3 times 4, minus 12, 3 times 2, 4, 0 times 3, 0. Third row, third column, minus 3 times minus 2, plus 6, 2 times 3, 6, 0 times minus 5, 0. So we see we have 1, that's 1, this is 8, this is 4, this is negative 1, 16, plus 15, that's 31, 31 minus 2, 31, that's 29, minus 8, minus 8, that's minus 10, minus 35 minus 36, negative 36. Here we have negative 3. Here we have negative 8 minus 12 plus 4, negative 8, and 12. Okay, the transpose of a matrix. See, the transpose of a matrix is actually a new matrix whose rows are what? Are the columns of the original matrix, or let's just say of the original. Good. So what does that mean? It means that this it makes the column matrix. It makes the columns of the, not the column matrix, it makes the columns of the matrix, which is the new matrix, the rows of the what? Of the original. Okay. Like, let me give you for instance. Its transpose. So consider this matrix and its transpose. We have the matrix A equals to 5, 4, 4, 0, 7, 10, that's a minus 1 and 8. Then AT, T here means transpose, the transpose of A. It's the same thing as 5, 4, 4, 0, 7, 10, minus 1, 8. Okay, the transpose of this, you see, you are told that you're told that the transpose of a matrix is what? The new matrix whose rows are what? The columns of the original. Now, these are the rows, these are the columns. This is the original matrix. Okay, these are the columns of the original matrix. Now these columns are going to become the rows of the new matrix. So what you just did is what? We take this matrix, the transpose of this matrix will be 5. This row becomes the column, this row becomes the column. So we have 5, 4. So rows switch to columns. 5, 4. This row becomes a column. That's 4, 0. This row becomes a column. 7, 10. And this row finally becomes also a column. Minus 1, 8. Okay. So you see the difference. So you see that. Therefore, the transpose of A, the matrix 5, 4, 4, 0, 7, 10, minus 1. It's, by the way, this is a 4 by 2 matrix, right? And the transpose is what? A 2 by 4 matrix. Okay? Just for fun, A times its transpose is what? Does it exist? Let's find out. A is a 4 by 2 matrix, as we saw, and A transpose is a 2 by 4 matrix. Oh, of course, we have 4 by 4 matrix. So A times A transpose exists. Okay. Find the transpose of A and B. We have a 2 by 2 and a 3 by 3 matrix. Okay. A transpose is actually 2104T. Remember, the transpose of this matrix means what? This row becomes the column of the new matrix. So we have 2 1 becomes 2 1, and this becomes the next column. We have 0 4, and we are done. B transpose is 1 2 3 0 1 5 2 3 minus 2, and this is clearly equals to what? This column, this row becomes a column 1 2 3. This row becomes a column 0 1 5. This row becomes a column 2 3 minus 2. So next is the determinant of matrices. Okay. We are only going to study two types of determinant. Methods. The first one is the 2 by 2 determinant method, and the second is a 3 by 3 determinant method. Sorry. For the 2 by 2 determinant method, so the first one is finding the determinant of a 2 by 2 method, 2 by 2 matrix, and this is by using the determinant, the 2 by 2 determinant approach. Now, to take, how do we do this? To take the determinant of a 2 by 2 matrix. Yes, 2 by 2 matrix. You multiply the top left to the bottom right, diagonal. And from this, we are going to subtract the product of the bottom left to the top right. Diagonal. What are we saying? If A is a matrix, A1, A2, A3, A4, then the determinant of the matrix A is simply what? A4 is denoted like this, and by the definition we saw, it is this product from this top, we multiply it like this, and then we subtract from this product. Okay, that is, we have A1 times A4 minus A3 times A2. That is the determinant. So I see that the determinant of A is A1, A4 minus A3, A2. For example, find the determinant of 1, 2, 2, 4. See, the determinant of 1, 2, 2, 4 is equals to this times this 1 times 4 minus 2 times 2, which is what? 4 minus 4, 0. Now to find the determinant here, you see that the determinant of P is the absolute value of that, 5 minus 3. We have 1 times minus 3 minus 5 times minus 2. So we have minus 3 plus what? 10, which is equals to 7. Okay. So the 3 by 3 matrix. A, A1, A2, A3, A4, A5, A6, A7, A8, A9. Okay. The determinant of A, which is A1, A2, A3, A4, A5, A6, A7, A8, A9 is simply equals to A1. You can construct something like this. It's not too long. Let's forget about that. A1. The first entry here is A1. A1 times, if you cancel this column and this row, we'll be left with this 2 by 2 matrix. Okay, so, and this 2 by 2 matrix is determinant, is what we put here. So we have A5, A6, A8, A9 minus this entry A2 times the determinant there. If you cancel this row, this column and this row, we are left with these 2. So we have A4, A7, A6, A9 plus the last one, A3. Then if you cancel this column and this row, we are left with this matrix. That's A4, A5, A7, and A8. Example 1. Find the determinant of A plus the determinant of B if A is the matrix. Let's have 1, 2, 3, 4, minus 1, 5, minus 3, 2, 0. And B is the matrix 1, 4, minus 2, minus 1, 2, 3, minus 1, minus 3, 5. Okay. We need to find their respective determinants. So the determinant of A, which is the same thing as this, is what? It's 1, 2, 3, 4, minus 1, 5, minus 3, 2, 0. Now the order of sign is positive minus positive. This is the order of the sign. So that means we have positive 1, the determinant of what? You eliminate this column and this row. So we have minus 1, 5, 2, 0. Then minus 2. Then we eliminate this and this. You have 4, minus 3, 5, 0. Then plus 3. You eliminate this column and this row. You have 4, minus 1, minus 3, 2. So it drops to the determinant of a 2 by 2 matrix. This times this, minus 1 times 0 is 0, minus 2 times 5, which is 10, minus 20, 4 times 0 is 0, minus 3 times 5 is what? Minus 15, plus 3 into what? 4 times 2, 8, minus 3 times minus 1 is plus 3. Okay. Of course, minus, we are saying minus because from the determinant of a 2 by 2, we subtract this product. We subtract this product from this product. So we have minus 10, minus 2 into what? 15, plus 3 into what? 5. That's minus 10, minus 30, plus 15. That's minus 40. And that's 5. Okay, is that 5? Minus 30 plus 15 is minus 15. Minus 15 minus 10 is actually negative 25. Negative 25. That's the determinant of A. Now the determinant of B, which is the same thing as this, we have 1, 4, minus 2, minus 1, 2, 3, minus 1, minus 2, 5. So, of course, positive, negative, positive. So we have plus 1, this matrix, 2, minus 3, 3, 5, minus 4. Minus 4, cancel this. We have minus 1, minus 1, 3, 5, that is. Then plus 2 is, okay, it's actually negative. So plus negative 2, making it what? Completely negative here. Because this is normally supposed to be plus the number of here. And this number is negative, so you have plus minus 2, which is minus 2. So you have negative 1, 2, negative 1, negative 3. So we have 1 into 2 times 10 minus 9. minus 4 into minus 1 times 5, that's minus 5, minus 1 times 3, that's minus 3. Minus 2 into minus 1 times minus 3, that's 3, minus 1 times 2, that's minus 2. So you see we have a plus here, that's 19, minus 4 into 1, this is plus 2, so we have minus 2 here, minus 2 into 5, so you see we have 19 plus 8 minus 10. 19 plus 8, first of all this is negative 2, so we have 17 as our result. Now we do what we call what is the determinant of A plus the determinant of B. So we have minus 25 plus 17. So we will obviously have 6 So that is the answer for this problem. A singular matrix is a matrix whose determinant equals 0. Okay, very important. Otherwise, it's called a non-singular matrix. Example 2. Find x if the matrix 2, 1, 0, 4, x minus 1, 0, 6 is a singular matrix. Okay. To solve this, we first of all look for the determinant of this matrix. Because this is plus, minus, plus. So we have plus 2. Cancel this, we are left with x minus 1, 0, 6, minus 1, cancel that, left with 4, 1, minus 1, 6, plus 0. Oops, this is a beautiful thing. That means this term will vanish. The term of 4x 1, 0 times 2, everything will vanish. So we have 2 into 6x minus 0, 0 times minus 1 is 0, minus 1 into 24, minus 1 times 1 is minus 1, plus 0. So we have 12x minus, this is 25, minus 25, as 2104 4x minus 106 is equals to 0, being what? Singular. See that we have that 12x minus 25 is equals to 0. So 12x equals to 25, or x is what? 25 all over 12. Okay, that is just it. Thank you.